So let's continue where we left off from last day. We're on page 226. Remember, if you want to right now, you can even do this. This is our z-score calculation equation, where we know what some of this means. Jordan, what does this little funky symbol right here mean? What letter does it look like? Does it look sort of like a handwritten M a little bit? If you use your... Does it look sort of like when you're writing a lowercase m, L, A, M? I kind of think it looks sort of like a lowercase m for mean. If you're wondering how I remember it, it's mu, m, mean. There's our average. What was this funky symbol? That was called a sigma, but what did it stand for? Remember? Okay, we need to remember this. This is our standard deviation. Okay? X was the data that they gave you. Z was your z-score. So, example 5, Boston says this. The average mark on an English exam was 63. The standard deviation was 12. You know what? Let's write that down. The mean was 63. The standard deviation was 12. If the marks were normally distributed and a student's z-score was 1.5, I guess that's the z-score, what was the student's actual mark? Now, the symbol that we used in our formula for the actual mark was the letter X, because this was the equation that we looked at, and I talked a lot last day, I know. Emily, this is the equation that we looked at during last day. We said that your z-score was equal to x minus mu all over the standard deviation. Let's fill in what we know. Do I know the z-score this time? Yeah, Alex, what is it? 1.5. Do I know x this time? No, this is what I'm trying to find. Minus. Do I know the average, the mean? Yep. Divided by. Do I know the standard deviation? Can I find x? Yeah. How? Please remember, please remember, please remember, please remember. This is cross multiply. This is once again, one fraction equals one fraction. Matt, I don't need to write the over one anymore, do I? You guys can just see it there and clue in. It's one fraction equals one fraction. So when I cross multiply, it's going to be 12 times 1.5 equals x minus 63, because there's a 1 down here, Boston. 1 times that would just be that. 12 times 1.5. Right, Liam? How would I get the x by itself? What would I do with this? Why divide? What mathematical operation? Yeah, always do the opposite, right? There's a little roadmap. So always just think, well, what are they doing? Do the opposite. So, if I hear you correctly, x is going to be 12 times 1.5 plus 63. If the average mark on this test was 63 and you know the standard deviation was 12 and you know the student's z-score was 1.5, what did he actually get? Johnson, 81? Okay. So he got 81%, which gave him a z-score of 1.5. What I'm saying, Shania, is this. Looking at the z-score equation, there are 1, 2, 3, 4 variables. I think I can give you any 3 and ask you to find the 4th one. Okay? Let's try another one. Turn the page. The weights of a large shipment of cantaloupes are normally distributed, that means they follow that bell-shaped curve, with a mean of 2.3. So we should write that down, shouldn't we? What was the symbol for mean? Mu. Who's in Physics 11, by the way? Or Physics 12? Any, okay. Yes, it's also the coefficient of friction. We run out of letters. We need an alphabet with like 100 letters, but that would probably be more confusing than it was worth. So 2.3. The weight of a particular cantaloupe is 1.7 kilograms. That's the actual weight. What do they want me to find in this question? By the way, we all just turned the page, yes or no? Did we? How about right here, we write z equals x minus mu all over the standard deviation. We're one page over. I don't think do you guys have this equation on the previous page still somewhere? Oh, okay. What number haven't I used yet? What is the z? What number has appeared in the question that I haven't used yet? 1.01. Now, is it positive 1 point? Am I going to go z equals positive 1.01, or am I going to go negative 1.01? There is something that tells you. Why negative? Ah, below the standard deviation, below the mean. Shay, so I put that all together. There's going to be lots of English in this particular unit, which is neat in some ways. Let's just do some neat applications. It's not neat in other ways. You got to read. Hey, let's fill in what we know then. Using this equation here, negative 1.01 equals 1.7 minus 2.3 all over the mystery standard deviation. Matt, how am I going to solve this? Cross multiply. When I cross multiply, it's going to end up being this times this. I'm going to write negative 1.01 times the standard deviation equals, what's on the bottom right here, Liam? It's invisible. So 1 times that is just going to be 1.7 minus 2.3. In fact, you could even evaluate that. What is 1.7 minus 2.3? Anyone? You got graphing calculator. Yeah, hello. What is 1.7 minus 2.3? That. And let's drop this down. I'm just going to treat this like it's an x or a y or a variable. How would I get the sigma? Yes, welcome to new letters, by itself. Divide by what? You're right. How would I get this by itself? Divide by this in front, right? Divide by negative 1.01. Yeah. What do you get? What's the standard deviation? What's the spread of this particular data? Sorry, I didn't hear. It's going to be positive, first of all. 0.59. Negative 0.6 divided by negative 1.01 to the nearest hundredth, 0.59. All right, example 7. How many of you are planning on going to post-secondary school at all? Many of you? Most post-secondary institutions grade on the curve. If you've talked to any of your older siblings who've gone to university, you may have heard some of them say, yeah, it was weird, our class average was 40%, but I got a B. I got 51, I got a B. Well, they've curved it. Because most profs, unfortunately, many profs, don't know how to create a fair test because they've never had teacher training. They just have training in their subject. So they do something like this. The marks on a math exam at a university were found to have a mean of 52 with a standard deviation of 12. The professor, who thought the exam was too difficult, decided to adjust the original marks by raising the mean to 65 while reducing the standard deviation to 10 and leaving the z-scores unchanged. Say what? What would the new mark be for a student who received an original mark of 34? Say what? Simon, there is a before and an after here, yes? Okay. Let's list everything we know about the before, let's list everything we know about the after, and then let's try and figure out what the heck they're trying to get at here. Before he adjusted the marks, oh, I know the mean. What was the mean after he adjusted the marks? Did they tell me? Oh. By the way, this question here is a tough question. This lesson is right from my old Math 12 book. This was once Principles of Math 12, and I would have said to my Principles of Math 12 kids, this is a B plus A minus level provincial exam curveball question. So if you find this one tough, you're normal. Not just on the normal curve, but normal like in real life. Okay, do I know the standard deviation before he changed things, Marcus? What? 12? Do I know the standard deviation after he changed things? Okay. So I've used this, I've used this, I've used this, I've used this. Oh, and then it says in the last sentence, what would be the new mark for a student who received an original mark of 34? They want the new mark. You with me so far, Shania? Okay. Shania, I'll pick on you because I said this to you earlier. How many variables are there in this equation? 4. How many things do I know here? Can I find the fourth? Yeah. How many things do I know here? I'm stuck there. In fact, you know what? I can use this to find the z-score before the prof adjusted things. It's going to be x minus mu all over standard deviation. The z-score is going to be 34 minus 52 all over 12. What was this kid's original z-score? It's going to be negative, I can see that much. Negative 1.5 even? Yeah, oh really? Okay. Now, Raylan, you notice it says he wants to leave the z-score unchanged. You know what that means? It means he wants the new z-score also to be negative 1.5. He doesn't want to change how the kid compares to the other students. He wants to move the whole class around fairly. Does that make sense? Okay. Oh! Now how many pieces of information do I have here, Joe? 3. And I can find the fourth. Ready? Same equation here. Let's plug in the numbers. The new z-score is negative 1.5. We want to find the new x value, his new actual score on his report card. You don't get report cards in college, but you know what I mean. The new mean was 65. The new standard deviation is 10. So once the prof scales this class, this kid who originally had a score of 34%, What will he end up with? How would I get the x by itself? What's the first thing I would do here? I wouldn't add 65. I'd cross multiply. I got right. Times by 10 first. Yes? Oh, you already did that. Awesome. So you're going to get negative 1.5 times 10 equals x plus 65. Oh, not plus, Mr. Dueck. Minus. Yes? Okay, Boston. How to get x by itself now? You are correct, sir. His new score is going to be negative 1.5 what's he going to get? Passes? Goes from 34% to passing. Okay. 50%. Raise him to a pass. That's how. Any of you have any older brothers and sisters that have gone to UBC, and especially in the math sciences or anything like that? I get emails all the time from my former students partway through the semester. Mr. Dueck, the class average is 51%. I got a 48 on my midterm. But then I get an email at the end of the year saying they finished with a B. What happened? This. Mr. Dueck, why don't we do this in high school? This is really only mathematically valid when you have classes of around 90 or more. Do they have bigger classes in universities? Yeah, lecture halls, yeah. Then it's mathematically valid because you've got enough students that you can make an accurate comparison. For example, if I only had 2 students, the average doesn't mean much because maybe you're really smart and maybe you're the opposite of really smart, or vice versa, or maybe you're both really smart. You know what? That small a sample, I really can't make any assumptions. Give me 100 or 200 kids in my class. Yeah, I can make some assumptions. So this is the idea of a Z-score. The key thing you have to be able to do after today's lesson, Emily, is if I tell you the actual score, the mean, and the standard deviation, tell me the Z-score. In fact, if I give you any 3 of these, find the fourth. So the homework I already assigned was number 1, number 2, number 3, number 4. I can now add number 5. What are they asking you to find in number 5? The mean, which means I'm hoping, Liam, they told you the other 3 pieces of information. Oh yeah, there's the Z-score, there's the actual value, there's the standard deviation. Number 6. Number 7. Number 8. Number 9. I already assigned number 10. I already assigned number 11. We're going to go 12. I also have for you, as promised, a take-home quiz, but can I suggest, because you're going to want to use your graphing calculators, it might be worth doing the quiz in class. It's very short. It's all of 1 page. You hit pause, I'll hand it out.